Hello everyone, welcome to our second vlog. This is Team Soundbite, and you're joined with Brandon Clark, myself, and Jiwon Kim.
hmm
So what we've been doing is we are planning to provide creators and hobbyists with a tool that prescribes audio files for that complements a given song when mixing. The goal is to improve the workflow of artists, while in the future even being a utility for DJs as they perform live. Our roles and responsibilities are as follows. Brandon Clark has been working on the machine learning component, the research, the science, and later the development. Brian has been working on the front end design and development, and he and I will share responsibility in the back end development. I myself am the Scrum Master and have been working on the back end and front end architecture. So, things that we've been doing this week and the week before. First of all, we've been addressing your commentary, and I hope that you all like what we've been working on. Brian, you can take the high fives.
Yeah, this is our application landing page. There's three options for the menu: suggestions, criteria search, and auto pairing. So the next page. Um, a user can upload a song or uh, suggested by parameters. And can you go next page? So whenever the user pushes the search button, there's some of the result list, and each result list has its own metadata, like such as um, sound wave and um, what kind of algorithm used for the list. And then can you go next page? Okay, this is the mixing demo result. So user choose only two of the results, and then go to and they go to and they can go to mixing results on the page.
One thing to note
I
about the
think
mixing demos option is that while we have planned for it in the user interface, it may not make it in our minimum viable products. So it is a goal we would like to achieve, but that does require another branch of machine learning that we might not be able to reach.
this is the second menu, criteria search. It has only parameter options, and then user pushes a button, search button. There is a waiting page, and then the next page, like the previous suggestion page, there is search list, and and the user can check the checkbox, and
Mm-hmm.
yeah, the user can mix two two results and mix the two results and get get the mixing demos for the next page. Yeah, this is the mixing demo results. And can you go to the next option? So this is auto pairing. There is only one big button, generate button, and user push this button. There is some waiting time, and then the last page. Can you go? Yeah,
Oh, sorry, we lost Brian again. So a quick summary is that the audio pairing, um, you can download the result. Simple
yeah.
as.
This is our hi-fi
Oh,
diagrams.
yes. So sorry, we're gonna have to move on. So going into the architecture a bit, to explain kind of how these MVPs fit in with those hi-fis. We made some user story maps, or sorry, some use case diagrams. So for instance, we have get suggestion, and then suggestion by feature. So you can either input the features yourself, or you can get a suggestion from the input that you've given, like the song input. In all cases, we accept similar results, The feature filter or criteria search does not use any machine learning. It's more of a filter based on, oh, give me every song ever based on beats per minute, things like that. An automatic pairing is a showcase of our science and of our model if you don't have input to give yourself. So that is essentially a quick explanation of like what's happening there on the hi-fis. Going forward, we also made our model view controller. It's going to be primarily written in, the model will be primarily written in Python, and we've done some research on adopting Amazon Web Service so that we can build our database more effectively, and I think a service would make it a lot easier. So that's a lot to read, so I'll leave that to the viewers. If you want to pause and take a look at some of our designs and our plans, we'll go more into Amazon Web Services as we continue. We also did some activity diagrams, so these are the stories, I guess, for those process. And then, of course, we then designed the activity diagrams of what would be happening. So this is kind of a mix of, this is like how the controller will be making queries to the model and then returning that, and then that's like model and view section, these activities here. And of course in the back end we would have, in the back end we have what happens when those queries are made. So from the activity diagrams we derived some class diagrams of what we kind of anticipate being on the front end and on the back end. So the front end and the back end share classes like songs, features, and filter specifications, whereas classes like suggestion is handled differently in the back end. So we have request handlers in these class diagrams, and then we have the suggestion class, which would call the request handler depending on which type of suggestion is being operated on right now. The same thing for filter. We also have a simple database commander which would be used for like, oh, get the song name that I've inputted, things like that. Just trying to find a way to make sure that we are communicating between front and back end. Then later on we created a brief class diagram of all these and how they might work together. I'm looking for a lot of comments, particularly on this, because I think this could be improved a lot. Namely, the middle section seems kind of pointless as it is, or perhaps we could get rid of the request handler. It just seems strange the way it's working right now, but I think it gives a good idea of how we're going to have things communicate. So in general, this would be like the API gateway, and then this is, I'm pointing at the screen as if you can see me pointing at the screen. API gateway, backend database model, Python, and then our front end JavaScript application being here. So definitely would like some commentary on this. It's a first draft, and I think we could benefit from some sequence diagrams and communication diagrams. Further, we are going to be pursuing these technologies as we begin developing our framework and our architecture. So we want to use Amazon RDS, but we might opt for DynamoDB if our data set can't fit. So Amazon RDS offers 20 gigabytes free, I believe, whereas DynamoDB is 25. And unfortunately, because we're dealing with songs, we might have to, that might be the difference that decides that. We want to explore using Amazon SageMaker, but as it is, it's not in our architecture. I think a lot of what we can do can be done with just AWS Lambda. And of course, communication between the front end and the back end, I think would ideally be handled with the API gateway. So Brandon can talk a bit about the machine learning.
Alright, so as far as the machine learning goes, we've now decided on a data set that we're going to use for this project. It's called the 1 million songs data set. I selected this data set mainly because it included metadata such as key, mode, tempo, and time signature, which I believe will be very much the meat and potatoes of what will make up the model that will drive our application. Also, I noticed it had some interesting metadata such as energy and danceability, which may be fun to play with in a stretch goal of some sort. And it also has a nice little feature for creating the data set for one, many, or all of the metadata associated with the song very easily into Python. As for the preliminary research as to constructing a model, my initial approach was to look at what's already available and how we can differentiate our service from that. So I started researching into kind of music streaming applications and how they suggest songs to users. And then I quickly realized that this is a lot different of an application than what we're going for. And most of that is based around data of many, many users of an application, and what one user is listening to correlates with what another user is listening to, so on and so forth. So my approach going forward is going to look at the data that we have a lot more and look at our desired input and see if any model will really afford itself well to what we're trying to do, and just kind of review some of my old class notes from machine learning and artificial intelligence classes.
Awesome. Thanks for the quick look and addressing a comment that one of our professors made. He had said that we should be working on this machine learning component and have something to show in the next week or 2 weeks, and we are attempting to reach that goal and at least have I don't want to say a stupid model, but yeah, like a stupid model to just show that it's making an attempt to suggest songs. So that's kind of our roadmap for that front. So this is what we have planned for the next week, 2 weeks, as we approach the end of the semester. Brandon will continue his work on the machine learning component, extracting features, training the model, and manipulating our data set, and of course iterating and improving that as we go. And I will likely in the future provide an advisory role, but given that I have to focus on the architecture and the back end, that is probably not going to be my priority. So Brian and I are going to attempt to become experts on the front end and back end front, so making sure that our JavaScript application is talking nicely to everything we've done with Amazon Web Services, and that involves setting it up and learning how getting its inner workings and everything really nice. So that's what we'll be doing. We'll be setting up Amazon Lambda and RDS or DynamoDB. We will explore AWS API Gateway and SageMaker. I think we definitely will be using the API Gateway, but I don't think we're going to immediately jump on board SageMaker. And basically our goal is to be able to handle simple requests from a simple front-end foundation. So yeah, after all that, our goal will be to build the simple web app. Other things, kind of side notes, is that we need to re-evaluate and define our story mapping since we've done a major shift in how we're doing it. This week has been I think, in my opinion, a huge turnaround. We could benefit from data flow, communication diagrams, object mapping, things like that, just so that the class diagram makes a bit more sense. And of course, sequence diagrams. I personally don't like sequence diagrams, but I understand their necessity. So we are behind on some things. We have some early documentation that needs a place on GitHub. So, for instance, jot notes, the messy stuff needs to be organized into something digestible by professors in the faculty and other stakeholders. So, update. You know, we need to. There's a lot of stuff we have that needs to now be updated since we've done this turnaround, and we just need to find time for that. So, yeah, things to remember is that we need to update past documents, and when a class document changes, that might change the sequence diagrams and things like that. And it's really good to stay up to date. So regarding, oh lord, regarding group reflection, we think that we've caught up a lot. We've addressed a lot of commentary that have been very helpful in kind of setting us on a better course. But we really need to get started on building the foundational infrastructure. I know a lot of groups have already started doing that, and I think we're ready to do that at a much faster pace now and catch up. Barriers to success, start to finish. This is the first time we've integrated these components, like making Lambda talk to RDS and making Lambda talk to the gateway and making the gateway talk to the front end. It's gonna be tough. So I'm a little worried about that. Going forward, some help. We would love to see or get assurance or criticism on our plans to make sure there is as few holes. So, for example, we've listed some AWS components that we want to use and we are going to use, but are we missing things? Are there things that we've talked about that presents underlying anxieties? Like, are you saying, oh no, that won't work? We'd love to hear from you about that. So yeah, any commentary, just repeating that again, we would love that, especially before we start really getting into it. I think that wraps it up. This is our GitHub. It's up to date. You have our thumbs up of approval. We have been working hard to keep track with our Kanban and like actually list what we've been working on. Everything below stakeholder analysis is like, again, documents that we need to make available to you guys. And yeah, that's currently been how things are. I don't like to put things in done often, so there's a lot in review, but it's done unless you guys have some commentary, like I said. So thank you for watching. That concludes our presentation. This was probably more than 10 minutes. Bye, guys.
Goodbye.
Goodbye.